Opioids are one of modern medicine's biggest, paradoxes. On one hand, they're incredible at wiping out severe pain. But on the other, they're at the heart of a just devastating public health crisis. The very same thing that brings relief can be lethal. So, how does that happen? How does it all go so wrong? To really get a handle on that, we first have to look at the sheer scale of the problem. Okay, first, let's just lay out the stakes here. And this is not a small problem. The numbers are absolutely staggering. Back in 2010, the US had just over 21,000 opioid overdose deaths. Fast forward to 2022, and get this, that number exploded to nearly 82,000. That's almost a fourfold jump. And the root cause for the vast majority of these deaths, it's probably not what you're thinking. It's not a heart attack, not directly anyway. It's a failure of the one thing our bodies are supposed to do automatically: just breathe. And that right there brings us to the central question we're tackling. How can a drug that's designed to relieve pain end up stopping someone from breathing altogether? It just seems wrong, right? To figure that out, we've got to look at what makes some of these opioids so much more dangerous than others. So when we talk about the modern opioid crisis, we're really, in large part, talking about one specific bad actor: fentanyl. It's a synthetic opioid, and according to the CDC, it is the main driver of overdose deaths in the US today. And the reason for all this devastation? Well, it all boils down to one single, incredibly important word: potency. See, it's not that complicated. Not all opioids are created equal. You've got morphine, oxycodone, fentanyl. They're all in the same family, but their strengths are worlds apart. And when we're talking about what really matters here, that's a thing called respiratory depression, which is just the medical term for slowed or stopped breathing. Potency is literally the difference between life and death. And the difference in strength is, it's kind of mind-blowing when you see it laid out. So let's use morphine as our starting point, our baseline. Fentanyl is around 80 times stronger than that. And then you get to something like carfentanil, which is an unbelievable 10,000 times more potent than morphine. 10,000! This is why a microscopic amount can be fatal. It's the very definition of extreme potency, and it's right at the heart of this crisis. Okay, so we know what is causing the problem, these super potent opioids, but we still need to nail down the how. How exactly do these tiny molecules manage to just shut down our body's breathing system? Well, the answer is hiding deep inside our brain, in the part that acts as our breathing autopilot. The official name for this is opioid-induced respiratory depression. We'll just call it OIRD. It sounds complicated, but it's really a simple, deadly process. The drug makes your breathing get slower and shallower until it just stops. That's it. So the absolute key, is to understand exactly how an opioid can trigger that shutdown. All right, let's walk through this step by step. First thing you need to know, deep in your brainstem, there's this little hub of neurons called the pre-Boettinger complex. You can think of it as the pacemaker for your breathing. It's what sends out the automatic signals to breathe in, breathe out, all day, every day, without you even thinking about it. Okay, step 2. Opioids, like fentanyl, are looking for a place to dock in the brain, and they find these special sites called mu opioid receptors, or MORs for short. And guess where a ton of these MORs are located? Yep, right in that breathing pacemaker. Now for step 3. This is where it gets dangerous. When an opioid latches onto one of those receptors, it's like grabbing a dimmer switch for a light. It starts turning down that breathe now signal. And finally, step 4, as more and more opioid molecules flood the area and hit those receptors, that dimmer switch gets turned all the way down. The signals stop. Breathing gets dangerously slow, dangerously shallow, and then it can stop completely. That's asphyxia. But, thankfully, the story doesn't end there, because science has also given us a powerful weapon to fight back against OIRD. We have a hero in this story, a true rescue agent. And that rescue agent is a drug called naloxone. For decades now, it's been the go-to first-line treatment to reverse an opioid overdose and literally pull someone back from the brink of death. So how does this stuff actually work? It's pretty amazing, actually. Remember how fentanyl binds to that mu opioid receptor and turns down the breathing signal? Well, naloxone comes along, and it has an even stronger attraction to that same receptor. It basically shoulder checks the fentanyl molecule right out of the way, kicks it off the receptor, and takes its place. And the second it does that, The breathing signal is restored, just like that. It's a powerful, direct reversal. But, and this is a big but, there's a catch. Yeah, as incredible as naloxone is, it is not a perfect fix. It's not a silver bullet. The rescue mission becomes this frantic, desperate race against the clock. And the biggest opponent in that race? It's time itself. And here's the absolute core of the problem. We're looking at something called half-life. That's just how long it takes for your body to get rid of half of the drug. So for an opioid like morphine, you're looking at maybe 2 to 3 hours. But naloxone, its half-life is only about 33 minutes. You see the problem here, right? It's a massive mismatch. The rescue drug wears off way, way faster than the drug that's causing the overdose. This mismatch creates this incredibly dangerous situation called re-narcotization. Basically, the naloxone wears off, but the opioids are still floating around in the person's system. So what do? They go right back to those receptors, latch on again, and the person stops breathing again. The overdose comes roaring back. This is why you hear about first responders needing multiple doses of naloxone, especially for something as potent as fentanyl. And any delay, any hesitation in getting that help means the brain is being starved of oxygen, and that can lead to permanent brain damage, or worse, very, very quickly. And yet, here's the part that's just so hard to swallow. A landmark study in the journal Anesthesiology put it plainly. The majority of these terrible outcomes, these deaths, are preventable. They don't have to happen. We know the science inside and out. We know the mechanism. We have the reversal agent. So the failure here, it isn't a failure of science. It's happening somewhere else. Which leaves us with one last, and honestly, one really critical question. We know exactly how these drugs stop someone from breathing, and we have a tool that can literally restart it. So why? Why does the death toll keep climbing? The science is crystal clear. The real challenge, the one we're all facing, is how do we bridge this enormous gap between what we know and what we're actually doing to prevent these deaths from happening in the first place?